So these are going to be our notes for 3.6, which is going to be over the phylum Echinodermata, which includes starfish, sea urchins, sand dollars, and brittle stars, just to name a few. And if you haven't done so already, please go ahead and either pull up your own notes that you're taking to write down the pertinent information, or go ahead and open that doodle note sheet that I gave to you and come on down to where the Echinodermata phylum is. So these interesting organisms, I think we're pretty familiar with sea stars. And if you haven't seen them in person, maybe at an aquarium or when you've been at the ocean, but I think we're familiar with sea stars. But there are other organisms that are part of this phylum. And the phylum name Echinodermata literally can be translated into spiny skinned. So derm meaning skin and echino meaning spiny. So any organism that is included in this phylum is going to have a spiny skin. So if you've ever touched a sea star, think about how that feels and just pay attention to maybe the samples that are passed around in class to feel that spiny skin. Many of these organisms are going to be slow moving or sessile. So remember, once again, that is an organism that is sedentary and doesn't move. Sometimes they're so slow moving, you almost need a slow motion camera to see their movement and their mobility. They are radially symmetrical, which means that they have symmetry around a central point. So the two things that we know already, being that they are radially symmetrical, is that they can sense things from all around them and they must live in an aquatic environment. Sea stars are going to be a little bit more, and all echinoderms are going to be more advanced than our cnidarians, which were also radially symmetrical, and we'll explore that in just a moment. So, with these organisms, how they move and how they pump water through them in order to oxygenate their bodies is going to be a little bit more complicated. It's a very interesting system. They have an open circulatory system. So, similar to the phylum Mollusca, they will pump their blood through their body without vessels, but that's how they will oxygenate their cells. They have this specialized system called the water vascular system. And this is going to be really important. This is a specific characteristic that is unique to only echinoderms. So go ahead and highlight and underline this right now. What a water vascular system is it's where water is pumped in and around the animal's body. So there's going to be a specific opening that's going to pull water in. It's going to flush water throughout the organism, and then there's going to be another spot where the water's going to go out. Now, the other thing, aside from it helping oxygenate the organism, it also helps control these tube feet. So, this is the oral side, or the side that we don't see very much when we look at sea stars from above. But you can see their little like suction cup feet, and this is how they're going to be able to move. And this is powered by the water vascular system. So, that will we'll get more further into detail about how the water vascular system works in just a minute. We're going to delve deeper into that, but I do want to make sure that you have highlighted water vascular system because this also powers their tube feet, but it also enables them to oxygenate their bodies as well. So in terms of digestion, they have a very simple digestive system, but it's a complete digestive system. There is a mouth and an anus. So you'll see right here, this is the mouth, and we call this the oral side because this is the mouth side. So this is the side where you're going to find the suction tube feet and things like that right there. And what you're going to notice here is that the mouth will be on the underside, so the side that normally is on resting on the sea floor, and their anus, which is a completely separate hole, will be on the top. So I'll make sure and point it out when we're passing the samples around in class to point out to you where the anus is. The anus is actually on the side that we see most frequently when looking down at a sea star. The other interesting thing about how these things digest is that they do have a stomach. Many echinoderms will actually turn their stomachs inside out. So they'll push their stomach out into an organism that they're trying to digest, and they'll release their digestive enzymes that are in their stomach, and it will like dissolve their. They like to eat a lot of bivalves from the mollusca phylum, so a lot of clams and mussels and things of that nature. And I have a really cool video to share with you in just a minute. But they basically digest the visceral mass into kind of almost like a soupy matter, and then they like suck it back into their bodies. Super cool. So now the interesting thing about the support structure of these is that remember they're invertebrates, so they don't actually have a spinal column, but they have an endoskeleton. So endo meaning inside, which is made of calcium carbonate, very similar to the material that the spicules in the peripheral phylum for the sea sponges is made out of. And the reason why it's an endoskeleton, remember, all of these organisms have a spiny skin covering. So there's like a dermis covering that has the spiny skin. So when you actually find sand dollars on the beach, if you've ever, I know Hilton Head has a lot of sand dollars that wash up. You're basically finding the white versions are the skeletal remains because sand dollars are part of this phylum, and when they are living, they have like a brown, it almost feels furry coating on the outside of them. So that's their spiny skin. And inside of them is that white calcium carbonate endoskeleton. They're going to obviously reproduce. They're animals and they're living, and they are going to reproduce sexually. There's going to be an external fertilization that's going to happen where the eggs and the sperm are released into the water, and the eggs are fertilized externally, and then you have more baby echinoderms that are made. Some echinoderms have amazing regenerative properties. So, similar to the platyhelminths that we talked about when we were looking at the worm phyla, these organisms, most familiar, I'm sure you're thinking of like a sea star, can regrow its ray. Sometimes we call it an arm, but the rays or the arms of the sea star, if it's ever damaged by a predator or while it's trying to catch its prey, it can grow it back. Now, these organisms that we discussed have radial symmetry so they can sense things all around them, but they are a bit more complex than our cnidarians. Like I mentioned, they have a complex network of nerves that include eye spots at the end of each of their arms. So, this enables them to sense things from all around them. They have nerve cords that actually run down each arm that will send messages from the eye spots to the sea star to the water vascular system, which will actually help control the movement. Now, there are different 5 classes of echinoderms. I don't expect you to be able to recall the names of these classes because really more the reason why I'm sharing this with you is so you can see the variety of organisms that are included. So, if anything, don't focus on the class name, focus more on the organisms that are included here. So, the first organism that we're probably most familiar with are the Astroidea class, which is all the sea stars. In a separate class, remember, it goes kingdom, phylum, class. So the other organisms that are included in this phylum, but it's in a separate class, are the Ophiuridia, which are the brittle stars. And then you have the Holothuridia, which are the sea cucumbers. But you can notice all 3 of these organisms have that spiny skinned nature, which is what classifies them into this phylum. Also, you have the Echinoidea, which is going to be our sea urchins and the sand dollars. So those 2 organisms are going to fall into the same class. And then lastly, you have the Crinoidea, which are sea lilies and feather stars. So, like I mentioned, don't focus on the names of these classes. They're not as relevant as the 3 classes of mollusks because those names kind of tell you what kind of organisms fall into that. But the one thing I do want you to observe by looking at these 5 different classes of echinoderms is that they are all spiny skinned organisms, and you're going to find that they have this water vascular system that either enables them to move or allows them to push oxygenated water through their bodies. So this concludes our notes. Please make sure you check out the supplemental video that shows how they eat because it's super cool and you will want to know that for sure.